Okay, class, today we are going to solve quadratics, and quadratics are these polynomial functions where the highest exponent, or the degree of the polynomial, is a 2. So those are quadratics. So there's 3 ways we can solve quadratics: with factoring, quadratic formula, and completing the square. And yes, I do expect you to memorize the quadratic formula if you haven't already. Okay, so first off, we are going to solve by factoring, and I'm going to solve by the box method. If you don't know the box method, but you know another method and you're happy with that method, then you can use that method. Otherwise, if you weren't happy with your method, then let's go ahead and learn the box method. So for the box method, we're always going to start off with 2 numbers that add to be to that middle number, which is -10, and the same 2 numbers are going to multiply to be the product of your outer 2 numbers, which is 24. We're always going to set it up. So you just think about the numbers that multiply to be 24 and add to be -10, and those numbers are -6 and -4. So we're going to set up our box, and inside of our box, 3x squared goes in the upper right corner, the 8 goes in the upper left, bottom right, and then our number is -6x, and then our other number, -4x, go here, and then we take the GCF, so the columns, and if the first number is negative, it's negative, so the GCF is 4. The GCF of this column is 3x. Over here, it's just x, and the GCF here, because it's negative, we bring out a negative, and they both have a 2 in it. So our factors are 3x minus 4 and x minus 2. So this factors as 3x minus 4 and x minus 2 equals 0. And you really should double check that you get it. So you do 3x times x is 3x squared, x times -4 is -4x, 3x times -2 is -6x, and -2 times -4 is 8. So I get 3x squared at the diagonal, -10x plus 8, which is what we wanted. Okay, so we're going to use the 0 product property and set each equal to 0, and then solve. So they get x equals 2, 3x equals 4, or x equals 4/3. So we get 2 answers, 4/3 and 2. So those are our 2 answers. So we can check. To check, you just take your number and you plug it in. So for example, if we want to check 2, you plug it in and you get 4 times 3 is 12 minus 20 plus 8. So when I plugged in 2 for x, 12 minus 20 plus 8 does equal 0. So it checks out. Same thing would work with 4/3. So you can always check to verify you got the correct answer. Okay, number 2, you should notice this special factoring problem. This is the difference of squares. And they have a special factoring pattern. Okay, so if you see that this is a perfect square and this is a perfect square and it's a difference, you just take the square root of the first term, which is 4x, minus the square root of the second term, and do the same thing except with the plus. And then you set each equals 0. 4x minus 9 is 0. 4x plus 9 equals 0. And just solve. 4x equals -9. X is -9/4. Or 4x equals +9. X is +9/4. So you get x is plus or minus 9/4. And you can check it the same way by plugging it in. Okay, another factoring problem. So for factoring, what you have to do is first you have to set it equal to 0. Okay, so I'm going to subtract 4x from both sides. And I get 5x squared minus 20x. I'm going to add 5 to both sides, plus 20 equal to 0. I see that they're all divisible by 5, so I'm going to factor out a 5 using the distributive property. And then now I can divide both sides by 5. 0 divided by 5 goes away, so you have x squared minus 4x plus 4 equals 0. And we can use the box method for this, or you can just do factor by foiling. But just to make sure everyone's up to speed on the box method, we want 2 numbers that add to be the middle number, which is -4, and two numbers that multiply to be the product of the outer numbers, which is 1 and 4, and those numbers are -2 and -2. Okay, so we set up our box, and the first upper left corner is x squared, the bottom right corner is 4. You take those two numbers, -2, add on x, and -2, add on x. You take each of those, put it into the diagonals. Then you take the GCFs of your rows and columns. So the x, GCF here, you get a -2. Here it's an x, and the GCF here, they both have a 2 in common, and it's a negative. So this factors as x minus 2 times x minus 2 equals 0, or you could have written it as x minus 2 quantity squared equals 0 in either case. So if you wrote it like that, you'd set each of those equal to 0, and you get x equals 2 and x equals 2, or here you take the square root of 0 and the square root of both sides, and x equals 2. Okay, so it's x equals 2 twice. The reason it shows up twice is significant for graphing, which we'll get into a little later. Okay, so let's move on to the next method, which is solve by quadratic formula. So to solve by quadratic formula, first you have to set it equal to 0. Okay, so you have 2x squared plus 8x plus 14 equals 0. I see they all have a 2 in it, so I'm going to simplify it. So I'm going to factor out the 2 plus 7 equals 0. Divide both sides by 2. X squared plus 4x plus 7 equals 0. When I divide both sides by 2. And so now for the quadratic form, a equals 1, b equals 4, c equals 7. So I'm just going to plug it into the quadratic formula. So when I plug it into the quadratic formula, it's -4 plus or minus b squared minus 4ac all over 2a, which is -4 plus or minus the square root of -12 all over 2. And just as a side note, square root of -12, square root of -12, that's the square root of -1, square root of 4, square root of 3, because -12 is -1 times 4 times 3. Square root of -1 is I, square root of 4 is 2, and square root of 3 is square root of 3. So we write this as 2I root 3. So I'm going to simplify square root of -12. So this is -4 plus or minus 2I root 3 all over 2. And I see all terms have a 2 in it, so I'm going to factor 2 out of the top. So it's 2 times -2 plus or minus, got rid of that 2. So it's I root 3 all over 2. So I just undistributed the 2. So now they can cancel because it's with multiply. So -2 plus or minus I root 3. Okay, so that is the quadratic formula. Of course, this is an example with a radical and an I in it, so we have complex numbers. You will often have real numbers. And if we would have taken, say, example 3 and solved at this step with the quadratic formula, you would have gotten the same answer as x equals 2. So you can solve this one with quadratic formula as well. This one, when you get an imaginary number, we could not have solved this with standard box method or FOIL factoring. Our two options would have been quadratic formula, or we could have solved it through completing the square, which is actually our next one. So the next way to solve is by completing the square. You could solve this problem with quadratic formula also, but I do want to show you completing the square. And there's two completing the square examples, one where there's no coefficient of x squared and one where there is. Okay, so to start, bring the 4 to the other side. So you have x squared minus 12x, leave a space, -4, leave a space. And we're going to do these two at the same time. So we're going to write this left-hand side as a perfect square. So write as a perfect square, you take half of the middle number, which is -6, and then you square -6, which is a positive 36. And I added 36 here, so I'm going to add 36 here. So on the right-hand side, I end up with 32. So just to write it more neatly, x minus 6 squared is 32. I'm going to square root both sides, and this is plus or minus the square root of 32. or x equals 6 plus or minus square root of 32 can be simplified. 32 is 16 times 2. So just as a side note, square root of 32 is the square root of 16 times square root of 2. And square root of 16 is 4. So this is 4 root 2. Okay, so our answer is 6 plus or minus 4 root 2. And this is the same answer we would have gotten if we did quadratic formula. So that's solving by completing the square. So the last example that we're going to do is solve by completing the square when we have a coefficient of the x squared. So we're going to start off by bringing 11 to the other side. So 4x squared plus 24x equals 11. And then what we have to do is we have to factor out of the 4 out of both terms. So x squared plus 6x, we're going to leave a space, equals 11, and we're going to fill out these two terms at the same time. So it's 4 something squared. So we take half of the middle number, which is 3, and we're going to square it, which is 9. So we're going to add 9. So if we factored this term here, this factors as a perfect square here. So the thing is, we says we're adding 9, but it's really 9 times 4, which is 36 that we added. So we have to add 36 to the other side. Add those numbers up, you get 47. So we're going to continue solving. So here we have the additional step. We have to divide both sides by 4 before we take the square root. So x plus 3 squared is 47 over 4. Now we can take the square root of both sides. So we have x plus 3 equals plus or minus the square root of 47 over 4. And we can separate this as square root of 47 over square root of 4, and the square root of 4 is 2, so we don't actually have to rationalize anything here. So this is square root of 47 over 2. Subtract 3 to both sides, negative 3 plus or minus square root of 47 over 2. Only this has the 2. The negative 3 is not, but you may see it written as a common denominator all over here, because negative 6 over 2 is the negative 3. So you can see it written either way. This is what you would have gotten out of the quadratic formula if you solved this with the quadratic formula. So both of these are valid ways to write your answer. So of course we could have solved this using the quadratic formula. You would not have wanted to solve this by factoring because you wouldn't have guessed those numbers. Okay, so those are 3 methods. Solve by factoring, solve by quadratic formula, and solve by completing the square. And that is how we can solve quadratics. So have a good night, and I will see you in class.